So we're talking about integration methods here from 5.5. Our first method is you recognize, right? You recognize the derivative, and I can kind of have a sense here that I'm lagging a little bit. Is everyone able to hear me and see the screen fine?
Yes.
Thank you. And so sometimes it'll happen. The screen will get fuzzy, and you just got to let me know, right? So our first method is pretty simple. Second method is undoing the power rule. Right, so if I have an integral of x to the n dx, that's x to the n plus 1 over n plus 1 plus c. So if you think about the power rule in terms of a derivative, we're bringing down the power as a coefficient, right? So we're multiplying by the power. When I undo that, I have to divide by something to get rid of it, right? And then I'm reducing the power by 1. So here I'm adding to the power, and I have to do those operations in the opposite order, right? So I'm first adding to the power, dividing by the new power. Right? And this is undoing my informal version, undoing the power rule, right? How are we doing here? How's the speed? Am I going too fast? Ash is okay. Angel's okay. David's
Good.
okay. Eleanor, thank you. Tonight, thank you. Naya, thank you. Sarana, thank you. Josh, thank you. Nima, thank you. So let's do a real simple one, right? So just plain old x. So my power is to the first power, right? And I want to add 1 to that power and divide by the new power, and then add my constant c. So I get x squared over 2 plus c. What's nice about all of these integrals, okay, and if I did ask you for just some simple integral like this, you can always do the derivative and double check it, right? And so you'll see later on, I might have in the past said, verify your integral is correct by showing the derivative, right? So in that sense, you need to still make sure you can do the chain rule, the power, all of the derivative methods, right? Chapter 3 should be just completely mastered by you at this point. Quotient rule, product rule, all of that junk, right? Well, we had one before that I did with method 1, but I said, if I don't see that it's something I recognize, I should be able to use another method to do it, right? I had 1 over 2 square roots of x dx. So any coefficient gets to move in or out of the integration symbol, right? Why is that? I'm going to move that 1/2 out.
Because the rule that you can remove any constant multiplier.
Exactly. This is a sum, right? An integral is a sum. If you could think about that Calc 1 method where we had to add up the areas of the rectangles, right? So if each rectangle is 2 times that rectangle, then I can just factor out the 2, right? So it's simply factoring, right? Integration is a sum, and I can factor out anything that's a multiplier with it. I like to, when I teach derivatives, I say, okay, the constants go for the coefficients go for the ride, right? Same thing when you're undoing that. And of course, what's the connection between the derivative and the integral? What's the connection there? This is the fundamental theorem of calculus.
It's a kind of inverse thing.
They're inverse operations, exactly. So when you're taking a derivative, it's the inverse operation of taking an integral, right? So of course, if the constants go for a ride, if the coefficients go for a ride, when you take derivatives, they do the same with integrals, right? So this one is what? 1/2 times the integral of x to the minus 1/2 dx. And so now I see it's a power rule, right? I want x to some power, right? So I've got 1/2 of x to the minus 1/2. I'm going to add 1 to the power and divide by that new power. I like to have that, you know, that nerd pen where you click the colors. I don't like writing with those, but you know, when I'm writing, I'm trying to write in a new color what's changing. So when I look back on it, I could see it, right? So that's one thing that happens during a test. If you look back on your work, you can't really tell what you did where, right? And then if you start getting nervous, you get something wrong. So, you know, but I'll talk about strategies there. But usually the best thing is to take a quick look. If you can't see your mistake, start the problem over, right? That's usually easier. And then if you can color coordinate things, that does help. So I get 1/2 x to the 1/2 over 1/2 plus c. So I get square root of x plus c, and we knew that, right? But what I'm saying is, if you don't see a method working, it should be taken care of by some other later method, right? Like you're going to see that in 5-6 we learned something called integration by parts. It works almost every time. But why do it if you can just look at the answer? And if you can look at the problem and just tell me the answer, why go through this long method, right? That's why we're putting things in order of try this first. If that doesn't work, try this. Step 3 is a little bit weird, and level 3 is a little bit weird. I don't even know if I like my order of this. I might change this, but step 3 is just tricks, a couple of tricks. Add 0, multiply by 1. Long divide, complete the square. There might be others, but I'll just do a couple of these real quick. Oh, divide and conquer. So I don't know if it's the right space for this, but I'll show you what I mean by a couple of these. But then when we get to the more difficult ones, it's usually one of these tricks that come into play. Okay? So for example, if I had 1 over square root of x dx. Look, we've seen this one already twice, but it's missing something, right? If I had a 2 downstairs, I know the answer, right? So I make that happen. I say, okay, well, this is equal to 2 over 2 times 1 over square root of x dx. So I'm multiplying by 1 here. That's my trick I'm doing, multiplying by 1. But then I know numbers, coefficients, constants, these can move in and out of the integral, right? So now I have 2 times the integral of 1 over 2 square roots of x dx. And I think you can go right there. I don't think you have to show this middle step, but whatever you're comfortable with, you do, right? And now I recognize that, what do I have? 2 square roots of x plus c, right? This whole piece here is the square root of x piece, right? The antiderivative of 1 over 2 square roots of x is the square root of x. And then that outside coefficient goes for the ride. Divide and conquer is another one. Long division is another one. So when do I long divide? When the upstairs power is equal or higher than the downstairs power. And they've got to be polynomials, so I'll do one like that. Got x squared over 1 plus x squared dx. So this one, I'm looking for, what's the highest power of the numerator is x, it's squared, right? And what's the highest power of the denominator is squared. So in that case, I want a long divide, okay? And these tricks here that I'm talking about usually happen inside of more complicated problems. But I just want you to see a couple of them before we get to the really difficult ones, right? So this one is long division for me. And of course, I could try every other process, right? So I don't see that it's a level 3 trick. I'll go to level 4, level 5, level 6, level 7, level 8, level 9, level 10, and none of them work. I must have missed something. So it's a good place to come back and try something. So, but your key is, and what you want to write on your formula sheet, long divide whenever you have equal or higher powers in the numerator, right? So I know this is going to bother some of you, but it's okay. I'm going to long divide. Well, x squared times what is x squared? That's 1, right? And then I come back and multiply and then subtract, right? So I get minus 1. So there's my remainder. So this particular integral becomes 1 plus negative 1 over 1 plus x squared all dx. So I get the quotient plus the remainder over the dividend, right? Just like long division, right? 5 into 21 is 4 with a remainder of 1, so it's 4 1/5. So it's the quotient plus the remainder over what you were dividing by, right? Well, the first one, now look, I just did something. I'm going back to the beginning of my checklist, right? Do you recognize the derivative, a derivative of 1? Where did this, so this is 1 dx minus the integral of 1 over 1 plus x squared dx, right? So do you recognize the first integral? Yes. X, exactly, Chuck. So I get x minus, do you recognize the second one? Charlie, you got it?
C inverse tangent.
Nice, arctan of x plus c. And of course, what's nice about all of that is, again, I can easily check it, right? Easily check it by taking a derivative. I like these problems in that I don't even need to go to the back of the book to see if I'm right. I can just do derivatives. As quickly as I could turn to the back of the book, I can do a derivative, right? Or I hope so. So you'll see a couple of those other ones come into play as we move forward. You'll see an add 0. You'll see a complete the square. You'll see a divide and conquer. Divide and conquer simply means take a multi-term numerator and split it into a bunch of fractions, right? That's all it is. But you'll see me talk about that several times this semester. Nice. How's it going? We okay? Does it feel like a review? Well, for my past students, it better feel like a review, damn it. I spent a lot of time on this stuff in Calc 1, so good. We're ready now to start doing our U-subs. So this is a piece I call undoing the chain rule. And by the way, this is a very long class, right? And so I do plan on taking breaks, but you are feel free to take a break anytime you need to, right? You don't have to ask. It's the same on a test, by the way. If you gotta go, you gotta go. You don't have to ask. You are human beings. You are free to do whatever the hell you want, right? So if you need to take a break, that's fine. I feel like, if you're falling asleep, you can go take a quick walk, get something to drink or something. You know what I mean? But you gotta try and stay engaged as much as possible. Unfortunately, if you miss a class and don't try and do the work on your own, you're probably in trouble. I say if you miss 2 or 3 classes, you're probably going to fail. It's in my syllabus. If you miss 5 classes, I can just drop you, but I can't stand doing paperwork, so I'll just so just try and be here, right? Okay, so our next 4 levels are 4 levels of U subs, of undoing a chain rule, right? So, and again, who cares about my levels? Okay. And we're talking about undoing the chain rule. And also known as U subs. Oops. What did I do? So there's really 3 levels of U subs, and I want to look for them in order. They'll all be pretty obvious. And then the 4th level it's one of the levels that I did, but I have leftover x's. And so then I do something called change of variable. These are all really change of variable. I'm changing from the independent variable x into the independent variable u. Why we do that is kind of, I think it's because it gives a chance to. It looks like I'm cursing and sounds like I'm cursing in Italian when I say F you. So I don't know how other math teachers don't tell that joke, but I guess because they're not as rude and crude as I am. But I'm from Jersey, so I have an excuse. So the first method is let u be f of x. Find du is f prime of x dx. And sub. So, but what you're really looking for is you're looking for a function and its derivative. Notice the function and the derivative. And so this is a U sub, but it's not really a chain rule piece, right? So I kind of misspoke there a little bit. Because if you look at the interiors of my functions, they're not complicated. That's in quotes complicated, right? The interior functions here are themselves, the derivatives of the interiors are 1. And so we really don't consider this a chain rule problem, even though it really is. But that's the key. So I'm looking for a function and its derivative. Someone name me a function. Give me a typical function. Didn't hear it, Chuck.
X squared.
Fine. What's the derivative of x squared?
2x.
All right. Well, this particular one, notice I don't even need, this is 2x cubed dx. This is a power rule, right? So 2x to the 4th over 4 plus c. So I've got x to the 4th over 2 plus c. That's really, I'm sorry it took so long to do that one. But that one, I don't even need to do this method, right? But what if I missed it? What if I missed that this was a simple power rule? Well, I can set u to be x squared. I see a function. I take the derivative of that. So du is 2x dx. And I'm doing differentials here. Are you comfortable with this differential piece? Where on the left-hand side, I'm taking the derivative in terms of u, the variable u. And the right-hand side, the dx is saying I got the variable, I got derivatives in terms of the variable x. So look, what's the derivative of u in terms of u? 1. Right? So I did the derivative of u. That's du. And on the other side, derivative of x is x. Sorry, is again 1, but that's dx, the derivative of x. Right? So, but the derivative of that x squared piece is that 2x. Is that making sense a little bit? Eleanor, I could cheat it a little bit this way too. Okay? I could say u is x squared. So du to d over dx is 2x. And then I'm not really doing this cross multiply. Right? I'm not really doing that, but it's a way to cheat it a little bit. So you want to just separate those differentials. On one side variable u, on the other side variable x. So when I'm taking derivatives du and taking derivatives dx. And then whatever happens to be the derivative of it, right? So now I make my substitution, right? I'm going right from here. So I get the integral of x squared times 2x dx. What is x squared? That's u, right? X squared is u. And what is 2x dx? 2x dx is du. And now look where I am. I'm now at a completely different independent variable, right? I'm pretending now my variable x is the variable u. So I have u to the first power, and that's a power method. So I get u squared over 2. But what is u? It's x squared. So I get x squared squared over 2. And there it is, x to the 4th over 2 plus c. So if I could see an entire function and its derivative, I can do this u sub method. David, okay there?
So
go ahead, Eleanor.
with the where you had written the integral of f of x times f prime of x dx, is that just like an example of a form that we should be able to recognize?
Exactly.
Okay.
So when you're on your list and you get to level 4 and you don't see a function and its derivative, go on. Don't bother with it.
Mm-hmm.
You have to see a function and its derivative. So for example, what's the derivative of e to the x?
E to the x.
Okay, so if I had this problem, which is e to the 2x dx, this is a level 4 problem. It also happens to be a level 5 problem. So if I don't see it as a level 4 problem, one of my other levels will take care of it. Okay? But clearly u is e to the x here. I'm looking here, right? And then what's my derivative of e to the x? So du is e to the x dx. Is everybody understanding that differential piece? Is everybody okay with that differential piece? Where I'm taking a derivative of the left side in terms of u. I'm taking the derivative on the right side in terms of x. Right? And I'm keeping those operators in there. These are called differentials. So depending on who you had for Calc 1, they spent some time on the differentials. Right, but so what delta x was what? x2 minus x1. And delta y was y2 minus y1. Yes, you with me there? And as I let the limit as h go to 0 on both of these, I got some expression in x dx, and then some expression in y, right? Some y dy. So the differential made that delta x turn into a dx, infinitely small, right? Infinitesimal, right? When we took our derivatives. So, but you can see that the dx is related to what happens to the function x. The dy is related to what's happening with the function y. So what do I have now? I have e to the 2x dx is u du, isn't it? Isn't it the same problem? So I get u squared over 2 plus c. Sorry if I'm going too fast there. Slow me down. I think my coffee just kicked in. right? I made my u sub of e to the x, and then du is e to the x dx. So I get a u du. Now I'm back at the beginning of my list, or this is my second item, right? This is the power rule. So I get u to the 1. Antiderivative of that is u to the squared over 2. But u is e to the x. So I get e to the 2x over 2 plus c. Not bad, right? Not bad. So it looks like everything's turning into u squared over 2, but it doesn't. It doesn't always do that. So we'll do one, right, where we have like sine squared x, cos x, dx. This is a method from Calc 1, but you're going to see we're going to start to have sine squared cos squared, and then sine cubed, and sine cubed cos squared, and sine squared cos cubed, and all of those things. And that's a Calc 2 integration process. So the trigs are sometimes the toughest pieces in Chapter 5. So do I see a function in its derivative is the question. Good, Charlie. What do you think is the function?
Sin x.
Nice. So sine x is the function. Du is what? Cos x dx. If I picked cos x as my function and did the derivative, I would have gotten the negative sine x. The negative is not a problem, right? But the sine squared is a problem. I can't have a derivative, the du squared. That doesn't make sense. Right? We always want that derivative piece to be exactly what we have. So this is now what the integral of u squared du. Of course, I get u cubed over 3 or sine cubed x over 3 plus c. And I do those fast. I'm sorry, but you tell me to say, wait, Robert. Hold on. What'd you do there? How'd you get that? Right? Or just give me a speeding ticket. How we doing? We okay? So look for a function and its derivative. And that function could be to any power, right? That function could be to any power. So there's some pretty cool ones. And if you try all the ones in, I think I put more on that review page than there are in the textbook. But anyway, you'll see they'll come up. They'll come up all semester.
I might be jumping ahead,
No
but
problem.
what if the expression doesn't have it doesn't work as well as it does? How could we?
Exactly, and that's going to happen. And you gotta know I'm engineering this to make it easy right now. I'm giving you problems that work for each method. And so what happens if you try a method and it fails? 1, you don't freak out, right? 2, you say, oh, maybe it's another method, right? And I am not one to say to you, do this integral when it doesn't work. I am more of the type of teacher that says, do this integral using a u sub and show it works using the derivative. So I'm not trying to trick anyone. The course is difficult enough without me trying to trick anyone. Okay, so it's a good question. And what happens in Calc 1 is eventually things fail. And then we move into Calc 2, which is where we're at. And we do 10 or so methods more. And then they start to fail. And then we train you to do a couple of other things before we teach you this final method called the Maclaurin series, Taylor series, where we turn every function into a sum of polynomials. And of course, polynomials are very easy to differentiate or integrate. All right, let's go next method. So in this one, it's a u sub inside. So you should see f of g of x, and you should see a g prime of x. So this one is really the essential chain rule, right? You can see it, right? You see a function, and that function is a derivative, by the way. So let me not. Right? If you remember our chain rule, y equals f of g of x, right? Gives me y prime equals f prime of g of x times g prime of x. And so I'm saying this function here that I'm drawing, you're not going to see a derivative mark on it. But you're going to see a function with an inside function. And then hopefully that inside function, you see the derivative of that outside. Right? This is the chain rule, right? And so you know if you have trouble with the chain rule in Calc 1, you're still in trouble, right? So go find your favorite nerd on YouTube, and you can. So at this point you can go, okay, remind me of the chain rule, right? So you go Calc 1 chain rule, right? Or in YouTube, or you go doing the chain rule Calc 2. Or, you know what I mean? Anything. You'll find 8,000 nerds on there, more than that, showing you how to do problems. And there's nothing wrong with, well, I say there's nothing wrong with being a nerd because I'm a nerd, but it's a 4-letter word, but so is love. So this one, it should be really, really clear. It should be very, very clear that there's an inside that's complicated, right? It should be very clear that there's an inside that's complicated. So, for example, sine 2x dx. Right, do I recognize what I took the derivative of? Hell no. Is it a power rule? No, it's a trig function. Does it have anything to do with a fraction? Am I going to be right, dividing and conquering or long division? No. Do I see a function? Yes, sine. Do I see its derivative? Cosine? No. Do I see a function? Yes, 2x. Do I see a derivative? 2? No. So it's failed on every piece. Is there a clear inside? Yes. So I'm going to let u be the inside. How are we doing here? We okay? So there's a clear inside. So what's the derivative of the inside?
2.
Good. 2 dx, right? du is 2 dx, right? I know it's been a while since you've been, or maybe you haven't ever written it like this, but so now I try and make my sub. I don't know if it's right yet, but I try and make my sub and I return to my list again, right? So I try and make my sub. So what do I have now? Sine of 2x, that's sine of u. Oh, but I need a 2 dx, so I make that happen. I make the 2 dx happen. I multiply by 2, and I divide by 2. Right? So sine of u, there's my u, and there's my 2 dx. That's du. So I did go back to level 3. I multiplied by 1. I multiplied by 2, divided by 2. So I was at level 5. I went back to level 3. Now I'm back at level 1. What's the antiderivative of sine?
Minus cos of...
Nice. So minus 1/2 cos of u plus c. And u is 2x. And you'll see on WebAssign they'll write it like this a lot. David, I think we were talking before. Does this feel like I'm going slow enough and this is making sense, everything here? David? Yeah.
Yes, this is making sense.
Yes, good. Am I right? You can just hold the space bar down to talk real quick. You don't have to unmute yourself. You can just push the space bar down and talk.
Yes.
Yes, okay.
Yes.
Nima, this is feeling like a review, but does it seem useful, helpful?
Yes.
Yes.
Good.
I have a quick question.
I have go ahead.
Are we gonna have access to your lecture notes?
The recording, I can share this whole Surface Pro page as a PDF, but you wouldn't be able to see it dynamically. You would just see everything written final.
Right. Yeah.
Yeah, I can do that for you. Yeah.
Okay.
If you do that, it would be great because I can copy it and look at it in some detail.
Absolutely. And remember, if I am going too fast, you please slow me down. I know I have enough time to finish the whole course. I've been teaching this particular course now for like 7-8 semesters at this school. So there's plenty of time. I've done it in the summer 3-4 times already. It's just that you don't have time between classes, right? I said that before. That's the tough. That's what makes it tough. I mean, it's tough already, but this particular problem didn't need to be done with this level. Can anybody tell me how I could rewrite this original function at sine of 2x dx? Anybody see how I could rewrite this particular function?
2 sine x cos x.
Yep, so this is 2 times sine x cos x dx. And I could have done this with a level 4, right? I could have done it with a level 4. So I like u as sine of x here. And then du is cos x dx. Make sure I'm not losing anybody there. Everybody okay? From green to blue, and then my u sub in yellow. Everyone okay here? Serrano, yes. Thank you, Charlie. Nima, thank you. Nayan, thank you. So, probably all those trig identities you want on your formula sheet, right? All those horrible things from pre-cal. Sine of double angles, cos of double angles, sine of alpha plus beta, all of those horrible trig identities. Put them all on your formula sheet. So this one becomes 2 times the integral of u du, which is 2u squared over 2 plus c. Make sure that's okay. I'm going fast there, I know it. Right, the sine is u, cos dx is du, so I have a power rule again, right? So that's just u squared plus c. So that is what? Sine squared of u is sine, right? Yeah, so sine squared of 2x plus c. And so I better call this one C1, maybe this one C2, because they could be different constants, right? So I'm saying C1 minus 1/2 of cos 2x should be equal to sine squared 2x plus c. C2. And so that's a nice little exercise for you. Remember doing trig identities? And we're doing those trig identities. So I don't care about the constants, right? I don't care that they differ by a constant. So anybody have an idea of what to do here? I want to show these two. This is the two answers I got, right, from doing this integration two different ways, right? But it's not I'm not convinced yet. Well, the trick is to use your trig identity here, right? Cos of 2 theta is cos squared theta minus sine squared theta. So use that identity and see if you can simplify it to get it to be true, okay? Okay, so let's do another one like that, right? Let's do e to the 2x dx. Is there a clear inside? What is it, right? E to the x is normally my input. What's my new input? 2x. Is that an inside? Yeah, that's my input, right? So u is 2x. du is 2 dx. I have a dx, but I don't have a 2 dx. So I make it happen. I multiply by 2 and divide by half. Multiply by 2, multiply by 1 half. Right? Multiply by 2, divide by 2. Is everybody okay there? This is that level 3 trick. Multiply by 1. So I got 1/2 of the integral of e to the u du. But that's one I recognize. I know that if I took the derivative of e to the u, I would get e to the u. So I have 1/2 e to the u plus c. But u is 2x. So I have 1/2 e to the 2x plus c. Same answer I got before. Right, when I did it with a different method. I want to show you a quick website that I used Wolfram Alpha when I was in grad school. Wolfram Alpha, we used to give a free subscription to, but we don't do that anymore. I'm not sure why. But I liked Symbolab, and of course you cannot use this during a test. I just like going Symbolab. And I'm doing integrals right now, so I can see I can do any of these things on here. This is a pretty powerful, so definite integrals, indefinite integrals, improper integrals, we're doing all of these. So indefinite integral, that's when we're not finding areas, we're just finding antiderivatives, right? And I can just type in here my e to the x, so e to the 2x, right? And then hit go. So this is symbolab.com, and you'll see there's a sidebar there. So this is a nice way to do even problems, right? The even problems in the book you don't have answers for. So, but Symbolab will do them. And what's really nice is they show you the U sub they're doing, right? They show you the U sub they're doing. And so you can see the whole thing. So there it is. So pretty powerful for all of your courses coming up. The multivariable calculus, which is also with the Fourier series and the Laplace transforms, and there's Taylor-Maclaurin series for our class, ODE, ordinary differential equations. So if you're taking diffie-Qs, right? So there's all kinds of stuff in here. Pretty powerful. Don't use it on the test. I'll know anyway. Oh my God, what a long class, huh? Oh, what a headache. I find that if I take a about 325 milligrams of acetaminophen right before my class. I feel fine right around now. So it's not a bad thing. You know, people will think you're carrying around a thing of Tic Tacs. It's actually one of those big Costco versions of Tylenol, you know. It's a long class. I'm hoping that you're not doing more than one class. I think one of you is doing anatomy, physiology, and Calc 2. I think, yes, Big Brother is always looking. I like to look at, you know, how you've done in the past in classes, you know, and what you're doing in the summer, especially if you're taking a summer course. So just know if it gets too much, you're not alone if you are taking another class. I tried to, when I took, so I was a community college student, and it took me 3.5 years, including summers, to get out. Changed my major, dropped out, you know, all kinds of stuff like that. Actually, 10.5 years if you think about the time I dropped out. But I would try in the summer. I would take try and split the brain, right? I would take if I took a Calc 2 class, I would also take maybe a reading writing class, maybe a history class, or, you know, something just to not overwhelm myself. I would imagine Calc 2 and anatomy, physiology would be pure torture. But it doesn't mean you can't do it, okay? So, can I go one more? I think I can go one more, and then I want to leave time for if any of you want to talk to me, right? And if anytime you want to talk to me privately, I can put us into a private room so that no one else would hear the conversation, and that's fine with me. But anything you want to talk about today, or any worries you have, I suddenly went really blurry in my camera. Oh, there it is. All right, one more method. Can we handle it? All I need is 2 of you to say yes. Okay, great. Here we go. So this is level 6. We're going to substitute downstairs. So it's going to be pretty clear again that there's a clear downstairs. It might not always work, okay? You got to be okay with things not always working, right? Right? Like I'm okay that my first marriage, my first and only marriage failed because now my girlfriend and I get along great. It's okay if things don't work. Right? You still can learn from them. That's the thing. Is learn from mistakes. Or if things don't work out, move on and see what happens. Right? So, so this one is as simple as x over 1 plus x squared dx. Right? It's kind of interesting to look at 3 problems. 1 over 1 plus x squared dx. And then x over 1 plus x squared dx. And then x squared over 1 plus x squared dx. We can do all 3 of these right now. We can't do x cubed over 1 plus x squared dx though. Oh wait, we can, long division, right? So those 3 are interesting. We did this one already, right? By long division. We did this one is arctan, right? Inverse trig, inverse tan, and this one we're going to do right now. So this one is clearly got a downstairs, right? This one clearly has a downstairs. So let's see what happens if I let u equal 1 plus x squared. So derivative is 2x dx. I have an x dx. I don't have a 2x dx. So I make it happen, right? So I make the 2 happen, 2 times x dx, no problem. But I have to cancel that. I can't just do that. I got to also divide by 2. Now look at what happens to this green piece in here. And look what happens to this blue piece. Right? So what do I have? I have 1/2 of 1 over u du. Right? The green piece is du. The blue is u. I have 1 over u du. So that's 1/2 of the ln of the absolute value of u. You with me here? And u is 1 plus x squared. Do you notice anything about 1 plus x squared? It's always positive, so I don't need the absolute value.
Yeah.
So this is 1/2 of the ln of 1 plus x squared. Don't need that absolute value because it's never 0 or negative. And then, of course, from pre-cal, that 1/2 can come in as a square root. You're not quite ready to do that list of problems I gave you. Most of those problems are the last 4 levels. Okay, so don't feel anxious if you go look at it and you can't do all of them. All right, I think you can start homework 1 on WebAssign, or better yet, start the MindTap questions, right? I had said 1 to 57. We're almost, I think we got 1 to 30 something done today in the book. The book is too easy, by the way, just to let you know. The book is kind of too easy. So I supplement. I do a lot of extra problems. So, but I'm not going to do anything on the test that I don't do in class. Okay? I'm not trying to trick anyone. If you can do the most complicated problems I do, then you're ready. You're ready for the next level. Okay? With any teacher. All right. I don't know if I can teach anymore today. It's the first day back after a couple of weeks. But I do want to say, please stick around if you want to ask me questions. Right? Stick around if you want to ask me questions. You have plenty to do. You got your WebAssign to sign up for. Start reading the textbook. Start trying problems in the textbook in 5.5. You certainly can start the WebAssign homework 1. Read the syllabus. Okay. I think that's about it. But that's enough for the first day. I don't think you have 6 hours of homework to do tonight. I mean, but it will start. So, next class, I'm going to finish this 5.5 method and I'm going to do 5.6. So, and so 5.5, I've got 4 more methods to do. 5.6, there's 4 methods. It's all called integration by parts, but there's 4 different types of problems. So right already after Wednesday's class, you're going to have twice as much as what we did today, right? So take the Tylenol at the right time, right? Get some practice in on these U subs, right? Because they'll keep happening. All of these U subs will happen over and over again all semester.
So, Robert,
Yes.
Please, you're going to put this on PDF, you said?
Yeah, I don't know how I can do it yet. I might be able to share it right to your email. And that's what I'm going to try first. And then we'll just double check tomorrow that you've got it. If I should be able to do it this afternoon.
Thank you.
And then I'll post it on Blackboard. And then if there's trouble with it, just respond. You can respond. So if I send an announcement in Blackboard, you can respond to that, and it will come to my email. Okay.
Thank you.
But otherwise, if you want to talk to me, just send me an email directly, right?
Just lecture notes in my class last semester. The professor also used OneNote, and she just had a link to the OneNote in the syllabus, and we could go there.
I haven't done that yet. I'll try and do that, Eleanor. Thank you. Who was that professor?
Mary Wall.
Okay. If I can't figure it out, I'll ask Mary Wall.
Okay.
Thank you.
And would you mind just scrolling up a little bit? I missed a part of the notes.
Not at all.
Beginning.
Same page or?
Yeah, just the beginning of the number 6, the downstairs substitution. Yeah,
Yes.
That's great.
Yeah.
Thank you.
And what's nice about these U subs, it'll be obvious. There'll be an obvious inside. There'll be an obvious downstairs, right? There'll be, I think there's one where it's not obvious. There's one where it's not obvious, and you'll see it in the book. So the one that's not obvious is something like if I had 2x over 1 plus x to the 4th dx. So this one looks like a downstairs, right? This one looks like a downstairs, but this one's an inside. So where do you think the inside is here?
X squared.
Yes, x squared is the inside. So this is an arctan one. So whenever I see downstairs a 1 plus something squared, I want to be thinking possibly an arctan. So this one's a tricky one in terms of seeing that it's not a downstairs, it's an inside, right? So, but of course u is x squared, du is 2x. I said I wasn't going to do another one. So then I have 1 over 1 plus u squared du, and it's arctan of u, which is x squared plus c.
Yes.
So that's a tricky one, but you'll see that a couple times in the book. So look, if you got to remember, if you're in 5.5 and one of these methods doesn't work, it means you missed it, because they're not trying to trick you into trying to force a method when it's not right. They don't tell you which method to use, right? I will on your test. I'll say use this, find this derivative as an arctan. So then you know you're looking for the arctan tricks, and I'm going to teach you, which we'll finish next class.
Thank you.
Okay, so I don't want to do it anymore. Let me stop my recording. I wasn't supposed to record all of the other junk.